Hi everyone, this is Miss Afric here, and today we are going to be going through how to identify key information and graph an ellipse. Sorry, I'm covering up the title there. An ellipse, okay? In case you're not sure what an ellipse is, it's just kind of like a circle but squished or uneven. Sometimes people call it an oval. Looks something like this. It could be vertical or it could be horizontal. Alright, the technical mathematical name for it is an ellipse, and that's what we're going to be going through today. Alright, so first things first, let's write down the standard form equation for an ellipse. In order to graph and identify anything important from an ellipse, it needs to be in standard form. Okay, so let's take a look at what that means. Alright, this is one version of standard form of an ellipse. And what you should notice is it's very similar to the equation for a circle. And there's a reason for that. A circle is actually a type of an ellipse. A circle is an ellipse where these two numbers right here, a squared and b squared, are the same number. So that's what turns it into a circle. They're even. Right? Typically with an ellipse, they won't be the same number, and that's why we have an ellipse. They're uneven on the x side and on the y side. Alright, this equation could also be written with a and b flip-flopped, where b squared's underneath x and a squared is underneath y. Okay, we'll talk about what a and b mean in 1 second, but a is the bigger one. That's why either one of these would work. Okay, the key part to notice in regards to standard form is that it has to equal 1. That's what we mean by standard form. Alright, so if it ever isn't in standard form, meaning it doesn't equal 1, you gotta do something about that. Alright, some key information from here. The first key information should be familiar. It's the center of an ellipse, and we find it the exact same way we found the center of a circle. It is h, comma, k. So whatever those numbers are inside there, the opposites, so h, comma, k. Alright, then an ellipse doesn't just have 4 vertices like a circle does. It has 2 vertices and then 2 co-vertices. The 2 vertices are the ones on the longer axis. Right? If we look back over here at these pictures, there's always a longer axis. That's where the vertices will be located, and then the co-vertices will be on the shorter axis. We call the longer axis for an ellipse the major axis. Okay, so the vertices are located on the major axis. And the way we find the vertices is using whichever value is a. Alright, so a represents the distance from the center, center to the vertices. Alright, and because it's to the vertices, because it's on the major axis, which is the longer one, it should always be the bigger of the 2 numbers between a and b. Alright, so there's one important part, the vertices. Another important part, like I mentioned earlier, would be the co-vertices. Okay, for an ellipse, they're different distances apart, the ones on the horizontal side and the ones on the vertical side. So that means they get different names. And the co-vertices are the ones on the minor axis or the shorter axis. Alright, and the way to find those co-vertices is using b. Just like a, b is the distance from the center, but instead of to the vertices, it'll be to the co-vertices. So b is the distance from the center to the co-vertices. Alright. And since it's on the minor axis, the smaller axis, they will be the smaller number. Alright. Now there's one extra piece that's really important with an ellipse that we didn't see with the circle, and those are called the foci. Foci, that's plural for the focus point. An ellipse has 2 focus points, and it's actually extremely important because that's what makes it an ellipse. It has to do with those focal points. And the foci are always going to be located on the major axis. They're always on the longer axis. Okay. And another important point is that for an ellipse, it's always inside of the ellipse. So it's inside of the ellipse. The foci for an ellipse should always be inside. Okay? And the way we find the foci is using our foci equation, which is c squared equals a squared minus b squared. So we know a squared and b squared, that should be given to us in our equation. So to find c squared, that would be helping us find the foci, because c, similar to a and b, is the distance from the center to the foci, or to the focus point. Distance from center to focus points. Okay. So I know this seems like a lot of stuff, but don't worry, because we are going to be going through a couple examples together to make sure that we understand how to find this information and then how to graph it. Alright, so let's go ahead and take a look at example 1. This says find the coordinates of the center, the vertices, and the foci, then graph. And it actually should also say the co-vertices. Anytime we do an ellipse problem, we want the center, we want the vertices, we want the co-vertices, and then we also want the foci. 4 different things we need for the ellipse, as opposed to a circle, which had a little bit less. Alright, so to find the center, it should be relatively easy. You look at those numbers inside with x and y. In this case, there's nothing in there, so our center is going to be 0, 0, the origin. Alright, in order to find the vertices, remember, looking back up here, vertices have to do with a. So we need to figure out, of these two numbers, which one of them is a. Well, a is always the bigger one. So this one right here is actually going to be a squared. So a squared is 25. That means a is plus or minus 5, because the square root of 25 is 5. And the other thing I like to write down is in which direction. In this case, since 25 is underneath y, it's plus or minus 5 in the y direction. Alright. Well, remember, a is the distance from the center. So in order to get the vertices, I need to plus or minus 5 in the y direction of this center. So what I'm going to do is it's going to be 0, 0, but then I'm adding and subtracting 5 in that y coordinate for the center. Alright, and I can simplify that because I know 0 plus or minus 5 is the same thing as just plus or minus 5. So there are my two vertices, 0, 5 and 0, negative 5. Alright, to get the co-vertices, it's similar, except for co-vertices we use b, just like you can see above here. So this smaller number is going to be our b squared. That means that b is going to be plus or minus 3, and in which direction? Oh, this time it's in the x direction. So we will plus or minus 3 to the center in the x direction. And 0 plus or minus 3, that's really just plus or minus 3. So those are our co-vertices. Alright, the last piece we need are our foci, which means we need to use our foci equation. So that equation is c squared equals a squared minus b squared. Be careful with that equation. I know it can be kind of challenging since it's similar to the Pythagorean theorem but different because it's minus instead of plus. So just be careful. Alright, in this case a squared is 25 and b squared is 9. So 25 minus 9 is 16, and that means c is going to be plus or minus 4. And once again, I like to remind myself what direction that's in. The foci should always be on your major axis, which means it should always be with your bigger number, or a. Alright, a is in the y direction, that means our foci should be in the y direction also. So our foci will be from the center, 0, 0, and then we are adding and subtracting 4 in the y direction, which is just 0, plus or minus 4. So that's how we get all of our information, okay? The vertices, the co-vertices, the foci, and then of course our center. Now I'm going to go ahead and graph it. Alright, I'm going to start with my center, and I always label all my points, so there's my center at 0, 0. My vertices are at 0, plus or minus 5. So 0, 5, there's one vertex, and 0, negative 5 is another. And then my co-vertices are at plus or minus 3 comma 0, which means 3 comma 0, there's one. Negative 3 comma 0, there's another. Alright, now, one thing a lot of people tend to forget is to graph the foci, since it doesn't seem like you need it in order to draw the shape. But foci are extremely important, and you will get your graph wrong if you don't have them plotted. So I'm just going to graph it real quick right now. 0 comma 4, that's my foci, and 0 comma negative 4 is my other one. Alright, my ellipse is formed from connecting the vertices with the co-vertices. So there's my ellipse. Alright, if you had any questions on that example, make sure you go back and take a look at it again. Otherwise, I'm going to move on to number 2. Alright, now I'm going to go through this one a little bit faster to see if we're understanding where everything's coming from. Alright, one thing you have to remember, and I mentioned this earlier, is in order to graph it, it needs to be in standard form. Needs to be in standard form. And standard form for an ellipse means it has to equal 1. Alright, so here we should notice that this does not equal 1. It equals 64. But there's an easy way to turn it into 1, and that's just by dividing it by 64. But if I divide one thing by 64, everything must be divided by 64. Alright, so I end up with 1 on this side like I wanted. Right here, you can simplify this fraction. 16 divided by 64 is actually 1 over 4, so we've got y plus 3 squared over 4. And then same with this fraction right here. 4 divided by 64 is actually 1 over 16. So there's our standard form equation. Alright, now I'm going to find all my information, just like we did in the last one. Center, the vertices, the co-vertices, and my foci. Alright, this time we do have an actual center, right? There are numbers there. Remember, it's always the opposite, so it'll be positive 2 for the x and negative 3 for the y. So there's my center. Alright, to get the vertices, I need to look at a, which is the bigger one. Alright, this one right here is a squared, so that means a is plus or minus 4. And in which direction? Looks like the x direction. So to get my vertices, I need to plus or minus 4 from the center in the x direction. So it'll be 2 plus or minus 4, comma negative 3. Now we shouldn't leave it like that. We can obviously simplify that. 2 plus 4 would be 6 comma negative 3. 2 minus 4 would be negative 2 comma negative 3. So there are my vertices. Co-vertices is very similar. We're going to use the smaller number now, though, b. Alright, b is going to equal the square root of 4, which is plus or minus 2. And this time it's in the y direction. So again, from my center, I'm going to plus or minus 2 in the y direction. And once again, we can simplify that to 2 comma negative 5 and 2 comma negative 1. So now the last piece is my foci. Remember, we've got that equation, c squared equals a squared minus b squared. So in this case, that's 16 minus 4. C squared is going to equal 12. Alright, that means I need to square root both sides. Simplify the square root of 12. Alright, we've got 4 and 3, 2 and 2, so there's a pair. So this is actually plus or minus 2 root 3. And in which direction? Well, it should always go with my vertices or with my a value, so it'll be in the x direction. So for my foci, I'm going to add and subtract 2 root 3 to my x coordinate of the center. 2 plus or minus 2 root 3, comma negative 3. Alright, go ahead and plot those points. I'll give you a little hint. For this one right here, you're going to need to approximate using your calculator in order to graph it. Okay, so approximately what will that equal in order to graph it? But go ahead and plot those points, and then as you can see here, wait, there's one on the back for you to try as well. So if you flip it over right here, I want you to try this one also. Alright, make sure you give me that center, the vertices, the co-vertices, and the foci. And then see if you can do that graph also. Alright, if you're still confused on anything, rewind, check it out again. Otherwise, make sure you ask your teacher in class. Have a good night.